This is part 4 of the C# tutorial. In this tutorial, we will learn the data types in C#. So before proceeding with this video, please make sure to watch my previous tutorial, that is part 3 of this video series, where I have given an overview of MVC and routing. Also, we have seen some example of displaying output on output windows as well as on browser. Okay, so let's get started with this tutorial. So there are two kinds of data types in C#. The first one is value type and second one is the reference type. So what is value type data type? So a data type which holds a data value within its own memory space is called value type data type. It means the variables of these data types directly contain values. And on the contrary, a reference type does not store its value directly into its own memory space. Instead, it stores the address where the value is being stored. Okay, so let me explain it with an example. So here I have given two examples, one for the value type and second for the reference type. So you might have heard about like integer, float, double, decimal, boolean, etc. So these all are the value type data types. So here you can see int I equal to 100. So here we have allocated some memory for I variable. You can see the address of that memory location, and here you can see the actual value, which is 100, is stored into the allocated memory of the I variable. Okay, it means this is the value type data type and it stores the value directly into its own memory, and that is what is written here. So a data type which holds a data value within its own memory space, so it's gonna directly holds the value in its own memory. Okay, now on the contrary, we have the reference type like string, object, classes. Okay, these all are the reference type data type, and a string is also a class. Okay, so here we have taken a string message equal to hello world. So we have allocated some memory for the message variable, here you can see, and if you notice that it does not contain the actual value, which is hello world. Okay, instead of that, it is holding an address of some other memory location where the actual value is being stored. Okay, so here you can see the hello world where it is stored into the memory. The address of that location will be stored into the message variable memories. Okay, so this is what is written. A reference type does not store its value directly into its own memory. Instead, it stores the address where the value is being stored. So I hope this value type and reference type is clear to you. Okay, so here you can see we have these data types available in C# to use. Like in value types, we have simple types which consist all the predefined types like signed integral, unsigned integral, Unicode character, floating point, high precision decimal floating point, and boolean, etc. And apart from that, we have some user defined types like enum types, tuple types, struct type, and finally we have the nullable value types, which is an extension of all other value types with a null value. Okay, and in the reference type we have the class, and under that we have object and string, which are the predefined data types. An object is nothing but an ultimate base class of all other types. Okay, and a string is also a class. And further, you can create your custom classes like employee classes, and that will also be a reference type. And apart from that, we have, you can create your interface, array, and delegates as a reference type. Okay, so we will see an example of all of these types in later video session, but for now we will cover the simple types. Okay, now here you can see we have the simple types further categorized into 4 categories, like integral types, which will store the integer number, and then second one is the floating point types, which will store a decimal number, and then we have char, which will store one single character, and then we have boolean, which will store either true or false. So in integral types, we can see we have these types available to store the integer value, and each of them has some range. Beyond that, you cannot store any number. Like the S byte has the range -128 to 127, and which is nothing but a signed 8-bit integer. Signed means it will have a negative sign, means it will store negative as well as a positive value. Okay, and in case of byte, see, it is unsigned 8-bit integer. The size is similar, but it will always store a positive number. Unsigned means it will not have a negative signs. Okay, you can remember in this way. So similarly, we have short, unsigned short. So here you can see the short has the range -32768 to +32767, and it is signed 16-bit integer. Okay, and in case of unshort, so here you can see it will also always store a positive number, and it is also a 16-bit integer, unsigned 16-bit integer. And similarly, we have the integer, and integer will have the same range. Then we have uint, long, and ulong. Okay, so based on your requirement, you can use these data types, and most popular types is the integer. Okay, next we have the floating point types. So the floating point numeric types represent real number. Real number means you can have a decimal values also. So you can see we have 3 types available to store the decimal values, like float, double, decimal, and each of them has some min to max range. Like float has the max range 3.4 into 10 to the power 38, whereas double has the max range 1.7 into 10 to the power 308, and the decimal has 7.9228 into 10 to the power 28. And notice that the e represent this into 10 to the power 28. So instead of writing this, you can simply say e. Okay, so there might be confusion that which one you should be preferring. So in case if you want a large size to large number to store, so go for double because it has large size. Okay, like 1.7 into 10 to the power 308. Then you can go for float, and then finally decimal. Precision wise, the float has the least precision. It means after decimal it will give you 6 to 9 digits. Okay, and whereas the double will give you 15 to 17 digits, and that's why it is also called as double precision floating point types. Okay, and the decimal, notice that it will give you high precision. Like after decimal it will give you 28 to 29 digits, and that is the reason we use it into the financial and monetary purposes. Okay, and here you can see the .NET types also. Like floating point belongs to system.single, then double belongs to the system.double, decimal belongs to system.decimal. Next type we have the char, and which size is 2 bytes, and it can store a single character. Then we have the boolean, it can store a true or a false values. Okay, and now we will see the example in C#. So here we will see the example of all simple types. So first let me copy all types from this notepad, and let me paste it here, and let me comment the previous section, copy, comment, and then here I can just say these are integral types, and these are the floating point. Okay, and these this one is char and this one is bool. Okay, so I have taken the maximum value of each type that it can support. So S byte can store the maximum value 127, byte can store 255, short max value 327767. Okay, and now see, this is the integral type, so it cannot store a decimal value. Let me try to store it. So it will give you an compile time error. So cannot implicitly convert a double type. Okay, so by default it will become a double. Okay, so just remove, and if I give a negative number to it, no error. Okay, but I cannot go beyond this range. Like if I increase the value from 127 to 128, so it will give me an error. Like see, constant value 128 cannot be converted to S byte. Okay, so each type has some limit, and within that limit you can store the integer value. And notice that the byte has the max value 255, and you cannot store a negative value like -1. Okay, if I store it, see, constant value -1 cannot be converted to byte. Okay, so it is nothing but unsigned byte, this one. Okay, unsigned means it cannot store a negative integer. Okay, so the range will be 0 to 255, as I can show you here. For the integer type, we have the range 0 to 255, and this is unsigned 8-bit integer. Okay, now similar cases for short, unsigned short, then integer has the max range this, and if I change it to 48, then you can see cannot implicitly convert uint. See, uint means unsigned int, so this value comes under this value. Okay, because after this integer, it just come into the unsigned integer category. Okay, so that's why it's giving an error of cannot convert type unsigned into int. Okay, so a larger data type can store the lower data types values. Like you can store int value into unsigned int value, but again we cannot store a negative value. You should remember that. Okay, similarly for long, and then ulong, unsigned long. So this is the case of integer. Now come to floating point types. So the float value can be stored in this way. You can store like this: 3.4 E3, it means 10 to the power 3, and you have to use f as a suffix. If you remove this f, it will become double. See, the double cannot be implicitly converted to type float. Okay, so you should mention f as a suffix. Okay, and in case of double, it is not required to put d as a suffix. You can remove it or you can give it. Okay, it will not give you an error. See, so by default it is double. And then we have the decimal, and here you can see in case of decimal you should use m as a suffix. Okay, if you don't use, it will give you an error for the same, like double cannot be implicitly converted. Okay, so in case of float, use f, and in case of decimal, use m. In case of double, you can use d or you cannot. Okay, it doesn't matter for this. So the default value would be the double. Okay, now come to character. A character value can store a single character, like A or maybe B, C. You can store a single character. Let me store 1. Yeah, it's fine. And the boolean value can store a true or false value. Okay, now let me put a breakpoint here and let me run this project. So here you can see the value of each variable into this local windows. So here you can see the values of these data types. So the double, you can see in case of double, the value is 1.7 into 10 to the power 308, and the representation is 1.7e, which is not recommended for the financial or monetary purposes, and that is the reason decimal is being used. See, this is the very decent number and it can be used anywhere. And here you can see the char value is printed here, and then we have the is true, true or false. You can print in case of boolean value. Okay, and we will also see, let me stop this and let me do some minor changes here. For integer types there is no confusion, control KC. And then for floating points, I want to store something different value, like store 111 into 222222222. See, and the same value I will store into this and this. Okay, and let me comment this char and pool. Okay, we want to check out the differences. Okay, so after the precision, okay, now let me run this project. Now here you can see the float max value, just it will give you the 111112 and then decimal and 0, and then we have the double will give you double precision, and then we have this decimal max value 1 2. So decimal giving you more digits after the decimal, you can see, and this is why it is recommended. Okay, and one more thing, you can use so like if I take the example of integer, so instead of int you can take int 32. This will also work. Okay, let me comment this one, control KC, and just try to, and this is nothing but your system dot int 32. Okay, so let me print this. See, here you can see the value. Okay, so the .NET type of int is int32, and you can refer this slideshow to check out the .NET type. And whenever you convert a string into int, so you can prefer convert dot system convert dot int32. Okay, like you can have a convert function, convert dot int 32 1664. See, you can also convert to unsigned integer. Okay, it will convert, and you can store it into some variable. Okay, control KD. So this is the example we have just seen in this tutorial. So this is all about the simple types. So I want to summarize this. For integer, we can have a signed integral or the unsigned integral. Use them as per your requirement. The most important is using int32, and that can solve your maximum problems. And we have also discussed how to use the where to use floating point, double or decimal. So in case of size, go for double, then float, then decimal. In case of precision, go for decimal, then double, then float. Okay, so this is all about the simple types, and in next tutorial we will learn more types like enum, tuples, struct, nullable, etc. Okay, so this is all about the simple types, and if you like this video, then give a thumbs up and do share this among your friends. And if you are new to my channel, please subscribe my channel, and don't forget to press the bell icon. Okay, see you, bye bye.